earlier we used to conduct sessions only on cloud, okay, but then the industry is shifting with specific roles, specific job responsibilities, and what we have decided is to include Terraform as well as Docker into the particular mainstream syllabus. So I'll tell you, see, currently the industry is having a lot of job opportunities for DevOps engineer, site reliability engineer, and automation engineer, and for that specific job role or responsibility, cloud is a mandatory skill, as everyone know. And on top of that, we also need to have specific DevOps framework related tooling. So when I say DevOps framework related tooling, when it comes to infrastructure as a code, most of the customers, like I would say 80% of the customer, they use Terraform. And if the customer is using specific cloud platform, let's say AWS or Azure or GCP, so they also have their own infrastructure as a code tool. For example, AWS provides CloudFormation template, CDK, and similarly, Azure has Resource Manager template through which also you can deploy. If the customer is using single cloud platform, they can leverage the native cloud native IAC tool. But majority of the customers or enterprise customer, they are using hybrid environment or a multi-cloud environment where Terraform is their tool that they are primarily using. Okay, so we want to add this tool as part of the course syllabus. Okay, and then majority of the application that are getting hosted on the cloud is now containerized, right? And when I say containerization, so there are two important aspects. Docker is the base containerization platform where your containers will be running, and on top of that, if you have plenty of containers and pods, you have Kubernetes as a orchestration platform that will manage the entire containerized workload. And when it comes to AWS, they also have EKS. We will also discuss EKS in detail. Similarly, every other cloud provider like Azure or Google Cloud, they also have their own Kubernetes engine. Like Azure has AKS and Google Cloud has got GKE. So in this particular session, we will discuss about EKS, which is from Amazon, and you will be able to compare and study with other Kubernetes engines that is available in the market. And on top of that, see, generally we are expected to do some automation to enhance efficiency and so on. So see, Python is one of the go-to tool when it comes to automation. And if you are already familiar with shell scripting or PowerShell scripting, it's fine. Okay, so you don't have to really think too much about it. But if there is a need where you need to learn Python, Python is a easier language that could be learned in to perform automation. And on top of this, there are other tools which are used in DevOps framework. It's like continuous integration, continuous deployment, continuous testing, and so on. So this particular tooling depends on organization to organization. Some might use Jenkins, some might use Argo CD, some might use Sonar Cube. So there are different tools that are used. So for learning those tools, you might not have to spend quite a lot of time. So you can able to learn that tool either in the span of 3 to 5 days. Within a week, you can learn these tools. You just have to get a KT, and these tools are straightforward. So the plan of the course is to cover the primary three aspects: cloud, infrastructure as a code, and the Docker platform. So that's why we have decided to conduct a course including Terraform and Docker. Okay, so that's the plan. And so this course is planned for next close to 19 to 20 weeks. Okay, and overall we are planning to have a very deep dive discussion of 100 hours minimum. Okay, and so this will be a hands-on session. So you will see quite a lot of practical demos that we do. Even though it is a solutions architect associate level training, intermediate level training, we will start from the basics, from the fundamentals, and we will definitely discuss each and every services week on week. So I've already shared this particular document with you all. We will follow this specific document while we conduct the sessions every week, every day. We will open this document and we will um, uh, start with the topics that are planned for that particular day discussion. So today we are on day one. So day one plan is to cover the fundamentals of cloud, from general perspective as well as from AWS point of view. And we will also discuss the AWS geographical presence, their global infrastructure options. And we will discuss shared responsibility model. We will create a AWS free tier account, and I will just give you a quick walkthrough. So this is day one today, part of the AWS Docker and Terraform combo course. Any questions before we begin? Is the audio clear? Is my screen sharing okay for you? And any specific concerns? Are you able to see my screen in full view?
Is clear for us.
Okay, then fine. How about others? Can one of you confirm as well?
It's good.
Sure, then. Yeah. Then we'll start. Okay, let's not wait anymore. Okay. Fine, then I could see some of you have already attended other cloud sessions like Azure and AWS and in general. So you might have been familiar with the cloud aspects. So I've got some slide deck, okay, and I've also will use my Excel notebook for sharing some notes. So whatever session notes, the uh, reference document that we are using for the session, we will share it in our G Drive. So you will be enabled access through your Gmail ID. So you will be able to access the session notes, session recording, and the document that we are creating as part of the session. So I will get the Gmail ID from you later, one-on-one, and I will enable the access. So let's start with the cloud computing introduction. I know many of you have already got cloud fundamental knowledge, but still, let's try to understand few terminologies, few aspects so that you get familiar. Okay, let's before we get into the AWS specific terminology. Okay, let's start with general cloud terminology. So there are certain specific aspects that you need to know, and I will not spend too much time on that, but let's try to understand a few aspects like what is cloud service models, what is cloud deployment model. I will spend possibly 10-15 minutes each, and then we will get into AWS. Okay, so when it comes to cloud, so you can easily understand cloud by comparing it with analogy of a house, right? So cloud is about renting instead of buying. So you know what is the benefit of renting a house rather than buying a house, right? So when you go for renting a resource, you have to just take care of only the specific monthly charges. So you just have to pay the rent and whatever the maintenance, whatever the cost that comes out of the other management aspects. So you don't have to really pay for that. So it's just you have to pay only for the rented aspect. So this is just an analogy like you can compare by comparing it with a house where renting versus buying. And in general, when it comes to IT, so what Amazon says as cloud is delivering or delivery of computing services over internet. Okay, so when you say computing services, there are quite a lot of services that we consume as a customer. So they provide compute power. When I say compute power, they are referring to CPU, memory, and whatever GPU. All those things are referred as computing power. And we also consume storage. And you have been using Google Drive or OneDrive or similar online cloud storage platform. So similarly, AWS also have variety of cloud storage platform for block storage, object storage, and file shares. So we will get to know that in details. And we can also have our application having databases also hosted on the cloud platform. So they also have variety of database options or offering in the cloud platform. Similarly, like they provide you hybrid connectivity option. You can also have your own network in the cloud platform, and you can subdivide them based on your application environment and so on. So we'll get to understand all these things. And on top of this, there are quite a lot of 2000 plus services that AWS offers. And as you know, AI is the buzzword currently, and AI ML related services and IoT related services. So there are quite a lot of services that AWS offer in their platform. the platform that I'm referring to is the Amazon Web Services platform. So this is the platform through which we are accessing all the resources that AWS provides from their data center. So Amazon Web Services is the cloud services platform. So we call it as CSP, and in general as an abbreviation. So Amazon Web Services is the cloud services platform through which the consumers, the customers, the end user access quite a different set of products and services. So cloud is renting based on the demand instead of owning the hardware, right? So in other words, if you go in Wikipedia or other in general definition, they also have a slightly different detailed definition. So we can say on demand delivery of IT related services, any IT related services. It can be infrastructure, or it can be application, it can be databases via cloud services platform through internet with pay-as-you-go pricing model. So in this definition itself, you can see a lot of different important terminologies or word. On-demand delivery. So cloud is about on-demand. So when you compare it with your on-premises data center, if you have your own data center, or if you want to run application in your own server room or data center, so you have to go for procurement, you have to go for selection of hardware. It can be server or storage or network devices. So you have to purchase quite a lot of devices before you can configure and enable application on them. But in the cloud, it is on-demand delivery. So when you need a set of servers, or when you need a size of storage, or when you need a specific database to connect your application, you get it on demand, anytime, anywhere. So that's the, so anywhere in the sense like it is available through the internet. So which means like you can access it from anywhere in the globe, wherever you have internet connection, and they are providing the services through their cloud services platform. So cloud services platform here refers to the Amazon Web Services platform. Okay, so that is the CSP here. And then by default, all these services which AWS provides are accessible over the internet. But if your organization have restrictions in hosting the application on the public cloud platform, or if you are not allowed to access it through the public internet, there are quite a lot of options. You can access it through a VPN, or you can use it through a direct connect network, or even you can also have your own private cloud solution, like what AWS is offering through the public cloud as a private cloud solution also. So there are alternate options, but primarily AWS providing cloud computing services through internet. And next important point is pay-as-you-go pricing model. So based on the consumption, like electricity or any other utility services, like water consumption or gas consumption, you are going to pay only for the consumption that you are making. So you don't have to pay anything above what you have consumed. And similar to your electricity freebies, even in the cloud platform, there are certain free tier option, and there are certain limits until which you don't have to pay anything, and beyond that limit you might have to pay based on the tier. So the more you consume, the lesser the price. So it's that is how it is priced. I'll explain how the pricing works later, but for now, if you look at the cloud computing general definition from the internet sources, it clearly says you can access any IT related services. It can be application or databases or any infrastructure on demand through internet with pay as you go pricing model. So this is the standard definition of cloud. Okay, so yeah, you can also keep it so simple, like delivery of computing services over internet, or you can say instead of owning our own hardware, we are renting it on demand, renting instead of buying. So you can use any of these three definition as you wish. Okay, now coming to the competitors, right? So when it comes to cloud services platform, there are different vendors in the market. So number one is Amazon Web Services, Amazon. So they are available, they are providing services since 2006 to public, but they have already started utilizing it in-house within Amazon as a company, they have started utilizing the cloud computing concept since 2000, but for the general public it has been made available since 2006. I'll come to the AWS history, and I'll cover a little bit there, but for now there are quite a lot of competitors. Microsoft is providing Azure as a cloud services platform, and Google Cloud Platform is there, and they are number 2 and number 3 when it comes to cloud services platform through which customers are running their application. Now, see, these are all we can consider as benefit as well. It's not just the definition. Even if you think from a cloud benefit point of view, so you are able to access all the application infrastructure on demand anytime you need, and if you don't need it, you can very well decommission it. So it's based on the need. Okay, so you don't have to really keep them running, or you don't have to that's where cloud is a little different from on-premises. Okay, I will just give you another dimension here. So when it comes to on-premises, in order to run application, either we have a server room where you have all the servers, networking devices, rack, and so on, or else you have your own data center. If there are quite a lot of application, you need to have multiple servers running on multiple different rack for high availability and so on. So on-premises, it's all about capital expenditure, capital investment. So when I say capital investment, you have to pay for the resources before you even install or configure the application. So you have to invest in server hardware, you have to invest in storage, you have to buy server network switches or routers in order to have network connectivity in your server room. And if you want to have internet connectivity, you definitely need a router, firewall, and so on. So there are quite a lot of investment that we make in the infrastructure, and also we have to invest in development, application aspects, and so on. So there is quite a lot of capital investment. So capital investment is nothing but upfront investment before you even run your application. But cloud, it's like operational expenditure, OPEX model. So operational expenditure is you are consuming it, and based on the consumption, you are just paying for it. It's not about you don't have to invest anything upfront, because cloud provider like AWS, they already have their own data center where they have lot of infrastructure, database options, and there are quite a lot of hosting options they are providing already. And you just have to choose which data center is nearer to you, which region is nearer to you, and you can start running your application in the nearest data center based on the latency, based on the user locations. You can choose which data center you want. So currently AWS is having almost 123 availability zone, and 123 data centers across the globe. You can choose whichever data center you want closer to your user location and start running it there. So there is no upfront investment needed. You just have to run your application on existing AWS data center, and based on the bill that you get, you just have to pay for that bill. Okay, so that is the primary important benefit that you need to know. So cloud is all about operational expenditure. On-premises data center, your own data center, is all about capital infrastructure. So capital investment, so how you reap the benefit, so based on the return on investment. So whenever you run the application and when consumers are accessing it, you are getting the cost covered there. So return on investment is later here, but here you are talking about operational expenditure. And the primary challenge when it comes to on-premises data center is capacity management. Generally, if you have worked in IT before 15, 20 years, so you used to have a capacity manager part of your IT service management team. So in IT service management team, you have different role like capacity manager, and then you have the change advisory board, technical advisory board, and then there are a lot of service level management team members who take care of each and every aspect. So capacity management was a very tough job to handle, because your business kind of keep expanding. So when your application is running, for your application, you need quite a lot of compute power. So server with CPU, memory, and so on, and you need a lot of storage power, network connectivity requirement, and so on. So based on the different department needs, based on your application need, the capacity manager has to plan for expansion of compute, storage, and network well in advance. So what they generally do is they go and do capacity management and understand if there is a room for cleanup of servers, if there is a room for cleanup of data, so that they can reclaim some space and start utilizing them. So but capacity management is a tough job because people from different business unit, different departments, they generally don't maintain hygiene to clean the environment. So generally there is a quite a lot of wastage of resources in the on premises, so they call it a sprawling. So sprawling is too much in on premises. They waste a lot of resources for unwanted data or unwanted servers. So sprawling is very common in on-premises data center. But when it comes to cloud, since it is operational expense, since the bill is based on what you consume, generally the hygiene is better because people don't necessarily run servers in cloud. They don't unnecessarily store content in cloud because you have to pay for every GB that you are storing. You have to pay for every compute units, CPU memory that you are consuming. So there is a bill attached to it. So hygiene is better in the cloud. So capacity management is still needed on the cloud in order to ensure that you are using the right resources. So generally it is covered part of your FinOps practice. The FinOps team also handles the capacity management in an indirect way. So they tell different business unit, this is the bill based on your consumption, and the different business unit or departments, they look into the consumption. They go and check which servers are needed, whether they are consuming the right amount of storage, and then they do the cleanup exercise in an indirect way. But on premises there is a lot of challenge, so we have to guess the capacity as well. That is another big challenge when it comes to on premises. So generally they go in guessing. So they go when they go want to buy a server or when they want to procure some storage, so they ask the different business unit, they ask the application owner, business owner, they might have some understanding, and then they will come up with some kind of capacity requirements. Sometimes it might be under provisioned, sometimes it might be over provisioned as well. So it's all guesswork in the on premises. But when it comes to cloud, so when you run the application, when you run some infrastructure specific workloads, so over the period you will get to understand after 2 months or 3 months, you know what is the real CPU requirement. So you can do right sizing in the cloud even if you over provision or under provision it. So if there is a performance issue or if you have over provisioned it, you can right size it after 2 months or 3 months based on the actual consumption. So on premises it's all guesswork. When it comes to cloud, you have the option to right size it little later. So generally like this is done as part of the cost optimization or performance optimization. So when the performance is not up to the mark, you go and increase the capacity. You either go and add more CPU memory or storage. When you are seeing over provisioning, you go and reduce or resize the server, downsize the server to get better cost benefit. So in cloud, on premises, there is quite a lot of uh, cycles in order to run your application. So you have to go and choose what kind of hardware you want, what kind of infrastructure related aspect you want, and after that it goes for procurement team, and even before that it goes to the business owner or business unit for approval. And once the business unit approves it, it goes for procurement, and there is a delivery time, and there is a quite a lot of delay when it comes to running application on your on premises. But in cloud, you have self-service portal. You just go and create the resources immediately within few seconds to minute, and you can add more infrastructure, or you can have a clone of application in different geographical region within few minutes. So you can go global with your application in minutes. You don't have to really wait for infrastructure to come up. You don't have to wait for the procurement cycle to complete. So you have the existing data center from Amazon. You just have to go and run the system, run the application whenever you need it. And also in cloud, there are other benefits, like if you are having unused licenses, or if you want to bring your own license to the cloud, you can also bring it to the cloud, where you will get quite a lot of cost reduction when you are already owning the licenses. Like it might be up to 30% or 45% based on the license that you have. Like it can be your database license or OS license. Based on that, you can reduce the overall billing. So there are quite a lot of flexibility like this. And when it comes to availability, there are a lot of options that cloud provides, like availability zone, placement group, and other options. We will see that a little bit in a few minutes today. So at a very high level, these are the primary important benefits that you can see from the cloud computing definition itself, right? So behind the scene, Amazon AWS, right? So it is a virtualized data center. So Amazon data center is a virtualized data center. When I say virtualized data center, not all the applications or databases that you are running is not on the direct physical server. Instead, they have virtualization in their data center. See, different cloud provider has their own virtualization hypervisor. So when it comes to Microsoft, they have their own Hyper-V, which is their own hypervisor to run virtual machines. And similarly, AWS, they did not have their own virtualization hypervisor. So they started with utilizing the kernel virtual machine, which is from Linux based hypervisor or Linux based operating system. Then they started utilizing Zen hypervisor. It was customized Zen. It's not the exact Zen hypervisor. So when I say hypervisor is a operating system to run virtual machine. It is a virtualization OS. Hypervisor is equal to virtualization operating system. When you are having virtualization operating system on a physical hardware, on one physical hardware or one physical server, you can run multiple virtual machine using this virtualization or instances. Generally, AWS uses the term instances for virtual machine VM. So you can run multiple virtual machines on the same physical hardware. So AWS data center is completely virtualized data center. So they initially used the kernel virtual machine hypervisor. Then they had Zen. Then see, generally when they have different hypervisors from different provider, so they are lacking in enhancements, or there will be quite a lot of challenges in having this third party product utilized, right? So what they did is they came up with two options. One, they came up with their own hypervisor called Amazon Nitro Hypervisor. So this is the product that is used as a hypervisor in majority of the EC2 instances or majority of the virtual machine that we are running in AWS platform. So they are also providing option like VMware Cloud on AWS. So this is like using VMware vSphere. This is the industry leading hypervisor product or virtualization operating system. So they are also allowing the customers to migrate their existing virtual machine, which is running on VMware in their own data center, to AWS data center on VMware vSphere or VMware hypervisor, right? That option is also there. So there are quite a lot of hypervisor option that AWS provides. So there are different type of hypervisors are available. Even AWS provides virtual desktop also. I'll come to that little later. So it's not just about virtual server alone. Even virtual desktops are also available on AWS platform. So majority of the virtual machine or EC2 instances that our applications are running on is based on Amazon's proprietary hypervisor called Nitro Hypervisor. Similarly, there are some workloads which are running on VMware Cloud on AWS, where the backend hypervisor is VMware ESXi or VMware vSphere. So when we are talking about virtualization, this is important to know. The reason is, see, when it is a physical server, when your application is directly running on physical server, you have a lot of challenges. Just give me a second. I will come back. Yeah, just 1 minute. Fine. I'm just responded to a chat here quickly. Okay, so we'll continue. So when it comes to virtualization, so there are quite a lot of benefits. So you can easily migrate your virtual machine from one hardware to another hardware. If you want to clone it, if you want to create a template, if you want to create an image, so it is very easy to handle the virtual machine rather than managing a direct physical hardware. So if you want to migrate a physical hardware from one application to another system, it is going to be very tough. But when it is a virtual machine or virtual instance, it is easy to migrate, it is easy to clone, it is easy to copy. You can easily create a template or image. So there are quite a lot of benefits that you get because of this underlying virtualization concept. So when it comes to Amazon data centers, they are using their own Amazon Nitro at a very higher percent. There are a few more hypervisors which are running on the old legacy Zen hypervisors also. Okay, let's see if few people are joining in now. So just a quick recap. So today we are on day one. So we are trying to understand, discuss the module one, where we are currently discussing the introduction to cloud computing. You might have attended the basic cloud computing session before. So we are just discussing that, and we will be discussing the introduction to AWS followed by these topics. Okay, so this is just to share what we are doing now to the people who are joined late. Okay, any questions on the definition of cloud? Okay, so see, the reason for joining live session is to clarify your questions. You can interrupt me anytime. So wherever you have question, feel free to interrupt me, and then I can explain it again. And for people who want to ask questions in Tamil, you can ask at the end of the session. So I'll give you 10-15 minutes time for Q&A at the very end of the session. Okay, so this is about the cloud definition. So definitely you need to have some basic understanding. I know cloud has been there in the market for last 20 plus years. So many of you have already understood it, but just a quick overview of what is a cloud definition and what are the key important benefits that we are getting from cloud. So when it comes to Amazon, they are saying these 6 points as their key benefit when it comes to cloud computing benefits: capital expenditure versus variable expenditure. So you get quite a lot of speed and agility when it comes to deploying your application and managing and maintaining your application. And you can reduce quite a lot of expenses. That's what they are claiming. See, when it comes to expense, so if you are just migrating virtual machine from one data center to another data center, definitely it is not going to completely reduce the cost. So there is a little bit of reduction in the cost because we are not having the complete management and maintenance of the infrastructure. So that's where you need to understand what are the different service models that are available in the cloud and how each service model is beneficial for our customers. So there are quite a lot of services that AWS offers, and each of the services are subdivided into these three different service model. So we'll have a quick look at how AWS services are grouped into these three service model. When I say cloud service model, it is based on who manages what or who services what. Okay. So when I say who services what, there are three different major category: infrastructure as a service. So here AWS services the infrastructure, or AWS manages the infrastructure. So when we say infrastructure, infrastructure is what? The physical components, right? The server, network, storage, the virtualization layer. So this is completely managed by AWS in this case. So when AWS manages the infrastructure, so it is called infrastructure as a service. So when AWS manages the infrastructure and the platform, then it is called platform as a service. So infrastructure is the server, storage, and the platform is the runtime environment. So your application needs some kind of backend runtime. It can be Java, or it can be Python, or it can be any different framework. So the runtime environment is also managed by AWS here, and it is called platform as a service. So infrastructure and the platform is managed by Amazon. So in the third category, software as a service. So AWS manages the infrastructure plus the platform and the software also. Okay, so customer, we are just mere end user in this software as a service. So we'll try to understand what are the different services that we have in each of these service model. So each of these service model have got quite a lot of services. So primarily, so when it comes to platform infrastructure as a service, so I will take top 5 services here. So let's say EC2, and then Elastic Block Storage, S3, VPC, and then Elastic Load Balancer. There are many other services, so we can keep on listing it. But just to understand this concept a little bit clearer, I'm just grouping some of the top 5 services in under infrastructure as a service category. So infrastructure as a service. So in EC2, what AWS is going to manage is the infrastructure, which is the server, the network, the storage, the virtualization. AWS will manage it. So as a customer, we just have to manage only the instances. So instances in AWS is equal to virtual machines or virtual server. You can call it as VM, or you can call it as virtual server, but AWS calls the VM as instances. So in EC2 instance, customer just have to manage only the OS part. They have to deploy whichever OS platform they need, and what kind of application they want to install, and they will just manage and maintain it. The patching, the backup, the monitoring, all those aspects they will manage. The OS and application has to be managed by the customer in EC2 instance, whereas the underlying infrastructure completely. So I will just quickly show you the diagram, so that will give you a little bit quick perspective or understanding of what I'm trying to say here. So in this diagram, if you look at here, so these are the 3 different service model which I am explaining now. Infrastructure as a service, platform as a service, software as a service. In infrastructure as a service, you have the infrastructure, the network, storage, server, the virtualization layer. It is managed by the vendor. Vendor is Amazon here. AWS data center team, they are managing the infrastructure. So that's why we are calling it as infrastructure as a service. If there is a problem in the network switch, or if there is a problem in the server hardware, or if there is any issue with storage, so the AWS vendor, the AWS data center team, they are going to service the infrastructure. They are going to manage the infrastructure. They will take care of any fault, any issues on the infrastructure level. So that's why it is called infrastructure as a service. Any problem on the infrastructure layer, the servicing, the management is done by the vendor here. AWS data center team is going to take care of it. And in platform as a service, the infrastructure plus the platform, the runtime environment, any middleware components that you need, like your host integration, or message queuing, or any other middleware component that you need, including databases. All these are being managed by the vendor. Amazon team, AWS data center team will manage the infrastructure as well as the platform that is needed for running your application. So as a customer, we just have to develop the application. We can run the application on AWS cloud platform. Sorry. Okay. So you just have to manage the application and the data part in the platform as a service. In software as a service, the end-to-end infrastructure, platform, and the software is managed by AWS data center team. I will give you a few more examples. So in easier terms, so in infrastructure as a service, as a customer, we are just managing only the OS and application. So when a person or when a team is managing OS and application, they are generally called as system administrator for OS layer. Plus the application is managed by the programmers or the developers. They will take care of the development aspects. And when it comes to platform as a service, we are just managing only the application and its relevant data. So here developers is enough to manage the environment, right? And when it comes to software as a service, customer is just an end user. We are just consuming services from cloud platform and we are paying for it, right? So these are the three different role customer plays when it comes to three different service model. So elastic block storage, this is your block storage for your EC2 instance backend. So whenever you need a storage, you need some partition or volume to be created on your virtual machine. So we create elastic block store volume and we use it on EC2 instances. This is also um, kind of infrastructure as a service. And S3 is your object storage, where you can store data like you are storing it in your Google Drive. It can be for backup purpose, or it can be for archiving purpose, or various purpose you can use it. The simple storage service can be used. And VPC is a secure cloud solution, so virtual private cloud. It's customer owned network in AWS data center. Similarly, load balancing is for distributing the traffic to multiple backend virtual machines or applications. So this is also coming under infrastructure as a service category. So when it comes to platform as a service category, I will pick up few services, and you can just try to understand it. See, we are going to discuss all these services in detail. We are going to uh, create, manage, monitor, and do certain activities on each of these services. For now, you don't have to worry about all these terminologies. You will get familiar as we discuss the other modules. So I have explained the syllabus earlier, right? So for each week, we have planned to discuss each service or product. So EC2 storage. So you will discuss quite a lot of all these things in detail. We'll at least spend 5 to 8 hours for each of these service. So don't worry about it for now. I'm just giving some example to make sure you understand or give example for each of this service model category. So when it comes to platform as a service, primarily the app services, the Elastic Beanstalk is one of the commonly used service, and similarly Lambda is coming under function as a service, but still it is also subcategory of platform as a service. Lambda functions, you can also call it as function as a service, but still it is platform as a service. Similarly, you have got a Docker container as a service, Elastic Kubernetes as a service, relational database as a service. So there are other application related services like App Runner, Amplify, and so on. So I will just give top 5 examples here, which are used in the customer environment. So platform as a service, if you just want to deploy your application and then just manage only the application, you can go for Elastic Beanstalk. That's what I told you, right? In platform as a service, customer will only develop the application and will run the application in the cloud platform. So we develop, we deploy, and manage only the application aspect. The underlying infrastructure is completely managed by AWS, and also the runtime environment is also managed by AWS here. So it can be whatever framework that you have developed your application. If you have developed your application in Python or Ruby or .NET or whatever Java, so the underlying runtime environment will be deployed and managed by AWS in platform as a service. We just have to create application, and only developers are needed to manage and maintain the application here. So we don't need a infrastructure team or a system administrator, because the underlying system, the underlying infrastructure and the platform is being managed by AWS. So we don't need a system administrator here. So we just need only developer to manage the platform as a service offering product. So when customer is running their application on Elastic Beanstalk, we don't have to patch it. We don't have to monitor the underlying OS or virtualization layer. The AWS infrastructure team is going to take care of those underlying aspect. But when it comes to application and data, customer has to definitely manage it. Okay. So Lambda function, we can call it as function as a service. You just run whatever application function or specific event driven action, or we can just say these are all event driven application. Whenever there is an event, this particular Lambda function will run. We will see some use cases and demos later. Okay, so some people call it as serverless as well. Lambda function comes under function as a service. Function as a service is also part of platform as a service. So this is like without managing your underlying containerization environment, AWS is providing Elastic Container Service. This is also coming under platform as a service. The next one is Elastic Kubernetes Services. relational database service. So all these are good example for platform as a service. So here, as a customer, we just have to manage and maintain only the application running on the container. We just have to manage only the database layer, and that too only the databases layer, not the database engine. The underlying database engine is also managed by AWS. So you just go and select which DB engine you want. So it can be Microsoft SQL, it can be Oracle, or it can be PostgreSQL or MySQL. So you choose which database engine you want. The underlying platform here is the database engine. So underlying platform in platform as a service is managed by AWS. So AWS manages the DB engine. Only the databases are managed by the customer. So customer manage only the application here and only the databases and the associated data here. Okay, so next category is software as a service. See, there are quite a lot of software as a service option that AWS provides. We can just say workspaces. This is readily available. Virtual desktops option. You can also go for email as a service. They call it as work mail. And then we are conducting this session through GoToMeeting, right? Similarly, there are application if you want to collaboration like Teams or whatever, right? SharePoint. There are options they provide. AWS QuickSight is there, which is for analytics, and there are quite a lot of services for monitoring. They are providing CloudWatch. They are also providing managed Grafana. There are quite a lot of services which they are offering as a software, even in AWS, as well as there are quite a lot of services which they are offering in Marketplace. See, Marketplace is a common platform. So if a particular company wants to create their own application and make it available in Amazon cloud platform, they can also make it available in Amazon Marketplace. I'll show you where exactly you can find those application and software that are developed and hosted as a service from third party. So third party hosted application can be accessed from Amazon Marketplace. I'll come to that a little later. So I would say like CloudWatch, Grafana for visualization. So for monitoring, there are services that are available. So any questions on these three categories? Cloud service model is grouped into three categories: infrastructure as a service, platform as a service, and software as a service. Amazon Web Services platform offers products, features on all three categories. Okay, any question from anyone on cloud service model? Clear?
Yes.
Fine.
Yes, then it's clear.
Okay, then let's move on with cloud deployment model. See, cloud deployment model is based on the location, based on how the service is being offered and how the service is being accessed. So cloud deployment model. So this is based on the hosting model or based on the location of the service. So there are three different options: private cloud, public cloud. In fact, public cloud is the primary option. Let's start with public cloud in that case. So public cloud, private cloud, hybrid cloud, multi-cloud, and community cloud. See, community cloud and private cloud are more or less similar, but I will slightly explain what is the basic difference here. So, cloud deployment model, see, not every customer can run their application on public cloud platform. So, the reason is there might be some legal security restrictions. There might be compliance requirement where customer might not be able to run their application on public cloud platform. See, public cloud platform, it is accessible for every single general public, right? So any end user or any customer, any company can access the services from the public cloud platform like AWS or Azure or Google Cloud Platform. Anyone can come and access the services which are running on these platform. So since it is accessible for all general public, so it is called public cloud. So it is also accessed using public internet and that is also one of the reason it is called public cloud platform. So you can access it from the wide area network internet, and the customers who doesn't have any specific requirement in terms of standards, legal compliance requirement, they can run their application on public cloud platform, AWS platform. Similarly, there are customer who want to run their application specific to their organization or to their company. So company or customer want to have the application accessed only by their dedicated organization team members. So generally this is hosted on their premises. So there are quite a lot of options available. AWS is providing Outpost as a service where you can have a similar concept in your own data center, like how AWS public cloud offering is offered. And similarly, Azure Stack is there, and there are quite a lot of other competitors like OpenStack, CloudStack, VMware vCloud Director is there, Platform 9 is there. There are plenty of product that are available in the market, which can be used as a cloud platform in your own data center in your on premises. Okay, so this is generally accessible by your own organization, employees, or dedicated organization. Generally, this is accessed only on the intranet or VPN or only on the local area network. So it is not accessible on the public internet. So that's the reason it is called private. Private cloud is for a specific private requirement for a dedicated organization. So why this is needed? In general, not all the applications can be hosted on public cloud because of the legal reason, security requirement, compliance requirement. The company has to run their application on their own data center, and the data has to be residing within their own managed data center or server room. So that's the reason people go for private cloud environment. And the third category is the hybrid cloud. So some companies have a mix of applications. Some application can run on private, some application can run on public platform. Right. So in that case, it's pretty straightforward, right? And there are quite a lot of use cases for hybrid cloud. See, hybrid cloud is not about mix of applications. So some applications, privacy applications run on private cloud, and public apps run on public cloud platform. So you can go with this model, or sometimes what you can do is you can store the data in on-prem, and sometimes you can also do a backup or archival in the public cloud platform. Some customers are doing it, so they call it as offsite backups or offsite storage. So that is something you can also use, and also you can use it as a DR option. So your primary copy or active server can run on premises, and then the passive copy, the secondary copy of your server, can run on the cloud platform. And when there is a issue in your primary data center, the secondary data center server can take care of it. So you can also use it for business continuity. So you can also use it for disaster recovery, or you can also use it for business continuity, where you will have let's say this is more or less same. So the only difference is you can have either active concept. You can run both the server actively, or you can have one server active and one server passive when there is a impact on your primary data center, when there is a issue or when there's a disaster on your location or in your data center. The secondary copy can take continuity, and they can run the application on the cloud. So sometimes people can also use it for cloud bursting. So cloud bursting is a common concept when there is a business need or when there is a sales need. So based on that time alone, the servers can be increased, or the servers can be scaled out on the cloud platform. They can have 2 or 3 servers on the premises, and when there is a need, when they want to have more servers, they can expand the number of servers, and then when the business need comes back to normal, they can decommission those additional servers. So it is expansion of capacity based on the demand. That's what we call it as cloud bursting. And there are quite a lot of other concepts as well. You can run your application on public cloud, database can be on private cloud. So that is also a common concept, because data is residing on databases. So they can have the database on private cloud platform, and the front end stateless application can be running on public cloud. So there are quite a lot of use cases like this. Customer choose hybrid concept based on the need. They mix both public and private cloud environment based on the need here. So multi-cloud is, see, some application, if they are running on specific cloud platform, they get certain benefits. For example, running Microsoft Windows operating system or Microsoft SQL databases on Azure might be a cheaper option. So they go for AWS and Azure, or AWS with Oracle. Sometimes the databases, if the customer is using um, databases in an Oracle cloud platform, they can run their databases in Oracle and the application in AWS, something like that. And similarly, they can go for multi-cloud solutions. It can be AWS plus VMware concept. So it all depends on case to case. Okay. So it is using multiple cloud platform for their application, and it's generally, yeah, go ahead. Any question? Okay. Fine, fine. That's fine. So it is this one, community cloud is targeting a specific community. Okay, so it's like AWS is providing Gov Cloud specific to government entities. Similarly, for specific region, AWS is providing AWS China, AWS Germany. This kind of cloud platform is specific to a organization, or it's specific to a government entity, or it's specific to a particular country where only the companies which belong to that country can run the businesses. So we can distinguish the cloud deployment model into 5 categories: public, private, hybrid, multi, and community cloud. So maximum of the workloads are running on public cloud platform. So AWS, Azure, GCP are good examples. So we are going to focus mainly on AWS, which comes under the public cloud deployment model category. Okay, so this is what we are going to focus. We can also spend 5 to 10 minutes on one more aspect: cloud characteristics. And see, of course, there are some disadvantages in cloud. So we can also cover up few important points just for our basic understanding, right? So when it comes to, let's say, cloud characteristics, I've already covered some of the key characteristics of or key benefits of cloud. So we can pick up some of those points from here. Let's say on demand, um, and what are the other points which we can pick up from here? So cloud is self-service model. Okay. So these are all default characteristics of cloud. When it comes to cloud computing, you get services on demand. You can go and create the services without human interaction. You can directly go and provision EC2 instances or relational databases and so on. And the scalability is another important characteristics. You can scale your application based on the need. You can increase and decrease the computing resources, storage resources, and other aspects that you want. And the elasticity is there, and AWS has quite a lot of infrastructure category. You can scale up or scale down based on the need. And another characteristics is your pay-as-you-go pricing model. So you are paying only for the consumption, and AWS provides quite a lot of high availability option. I will explain that in global infrastructure shortly. Okay, next one is the fault tolerant options. So you have a lot of built-in redundancy that AWS provides across their region, availability zone, and so on. And AWS is also providing a lot of services to do your monitoring, logging, and observability option. We will see those services a little later. So these are all the top. Okay, let's cover a couple of more options. See, public cloud is generally a multi-tenancy option. So you have multiple different tenants, multiple different customers running services on the cloud services platform. So there are two different important aspects. The monitoring is different and metering is different. So AWS also has pricing calculator or billing options. See, monitoring is primarily to monitor the uptime, the services, whether it is running or not, whether there are any issues, health checks, all those things are done under monitoring. So the consumption is done under metering. So metering is mainly to understand how much each customers are consuming, and based on that the chargeback can happen, right? Chargeback is mainly to understand the charges, how many services are being consumed, how much resources are being utilized by each customer, and they also have a chargeback mechanism. I'll explain this specific things in details. So cloud has all these basic characteristics, top 10 characteristics. I've spent a lot of time in explaining it in other sessions. I might share it with you. You can just go through that a little later when you find some time. So now, when it comes to cloud disadvantages, okay, I'm not going to give quite a lot of points here. I will just cover top disadvantages that you need to be aware of when it comes to cloud platform. See, we are hosting our services on third party, which is like the third party. We don't know where exactly the data center is, where our application is running on which server, or which storage our data is stored. So that visibility is not there. So we are hosting our services on third-party data center where we don't have clear visibility on even the data center location is not clearly given. They are telling like the data center is in Mumbai, the data center is in Hyderabad, but we don't know where exactly the location is, physical location is, and we don't know our application is running on which rack, which server. That kind of visibility will not be there with us. If you are running it in our own data center, we know which hardware, which rack, which particular network is being used on the back end. So troubleshooting is pretty much easier. But see, we don't have to worry really about it because the infrastructure is provided as a service. So the AWS data center team manages the network issues, the infrastructure hardware related issues. They are fixing it, they are replacing it. So, but still, the visibility is what I'm highlighting is as a kind of disadvantage. And we also have less control on the business asset, the underlying IT asset. See, generally, the business, let's say, like when we are running our application, the customer, if they are from automobile, or if they are from manufacturing, or if they are from different industry vector, so their primary importance is to make sure that their application, their business application, is available to their end customer. Either they are from banking, or whether they are from pharmaceutical or healthcare. So their primary objective is to ensure their application is available. They don't have to really worry about their underlying data center or infrastructure or hardware. Here we have given that ownership to a kind of renowned provider, so they are managing it. So but still we are having less control on the IT assets and the business assets here. Okay, so next disadvantage can be um, lock-in or vendor lock-in. See, over the period we might start inclining to use cloud provider services. Let's say initially we might migrate it to let's say an application or the database to an EC2 instance. You will have full control on your OS and database. And later, what cloud provider will tell you is, if you are running your database on RDS platform, it will be 60% cheaper, or it will be 50% cheaper if you're running it on RDS. So customer generally tend to migrate their workload to Amazon RDS. And see, when you are migrating the services to their own platform, their own hosting platform, the dependency increases. And when you want to come out of their services, then you have dependency on the provider in order to come out of that particular platform. So over the period, based on cost benefits and performance benefits, customers might incline to use vendor provided services. That might result in a lock-in. Okay, that's what I'm calling it as the vendor lock-in. And here we have quite a lot of dependency on the internet network. Dependency is there. So if the network at the internet level, or if the WAN has some issues, so you will have challenges in accessing your services. So there is a quite a lot of network internet dependency, and also there is a quite a lot of network cost that might come because you are accessing all the services over the internet. And another thing is unpredicted cost chances are there. Okay, so definitely AWS provides you visibility. What are the services we are consuming, what are the products you are consuming, what might be the bill end of the month. That kind of visibility is there. But then as a customer, as an end user, we might create something and then we might leave it without properly decommissioning it or without properly utilizing it. So that time, like it is a unpredicted cost which might come in your bill. So these are top 5 disadvantages, I would say. There are other disadvantages that you will get to know when we discuss each and every service. So now just we have completed the first topic, introduction to cloud computing. Next we will try to understand some of the AWS global infrastructure and history of AWS. Okay, any questions before we move on to the second topic? This is just introduction to cloud computing. Okay, yeah.
Yes, got it. Um,
Yes, Lavanya, go ahead.
in cloud service model, can you please go
Yeah, yeah,
to the tab?
sure.
Uh, in IAS, you have mentioned S3 bucket, right?
Okay.
It will come in PaaS service or
See, it
in.
depends on our understanding, and in some documentation it might be different. But in general, like here, see, when we say deployment model, see, the storage is what is infrastructure here, right? The storage is being serviced by the provider AWS, and as a customer, we are managing the content which are stored in that particular physical infrastructure. So the storage is being managed and maintained by AWS, and also if you are familiar with the storage hardware also has its own iOS. Okay, so it has its own operating system. So that operating system is also being managed by AWS here, and they are also managing the physical storage data or capacity. So it's a good question, because like some people call it as platform as a service, because we are just managing only the data that is stored on that particular cloud storage platform. But in general, S3 is infrastructure as a service category, because the underlying physical operating system, as well as the physical storage, what do you call, the disk, and the firmware, all those are being managed by AWS here. So when there is a problem with your underlying storage component, AWS is servicing the infrastructure, and it generally comes under infrastructure as a service category.
Okay, okay, stop.
Yeah.
Thank you. Got
But
it.
it's not wrong calling it as platform as a service, because we are just managing only the data part of it. So it can be classified as platform as a service as well. But yeah, primarily, see, generally when you consider infrastructure as a service, people refer to EC2 instance as the primary option, and beyond that, rest of them can be classified into different categories as well. And there are quite a lot of subcategories in platform as a service. For example, some people call it as database as a service, function as a service, container as a service, but all of these comes under the platform as a service. So in some documentation, you will feel the different terminology or different classification, but they all come under platform as a service category. Even storage as a service also, in some documentation, you will see it under platform as a service category, but it's not a big I mean, it's you can it all case to case, you can consider that under infrastructure as a service or platform as a service. Okay, so
Okay,
let's do
okay.
one thing. We will take a small break here, and then maybe 10 minutes break, and we will continue with the remaining topics. Okay, so I will stop the recording for 10 minutes.
Not hybrid cloud, multi-cloud.
Okay.
So for AWS and Azure, whether we are anybody is still using in the market that option.
Yeah. See, majority of the customers are now adopting multi-cloud for various reasons. See, multi-cloud in the sense, let's say there are benefits in terms of cost when you're running specific products on specific cloud platform. Let's say like Microsoft workloads, like Microsoft Windows OS or Microsoft SQL databases. These are definitely cheaper on Azure platform. Okay, so customer, if they have application which are predominantly running on Microsoft workload, they choose Azure, and for other workload, they might choose AWS. And see, these data centers, right? For example, Oracle, Azure, AWS, they have cross-cloud interconnect option. So even if you have workloads running on two different provider data center, their two data centers are interconnected using cross cloud interconnect in majority of the region, majority of the location. So if you are running it on two different data center using cross cloud interconnect, it might seem like a same local area network. The performance might not be challenging, and the performance might not be the latency will not be that much there. So there are use cases, there are customers who are using AWS and Azure, AWS and Oracle for different workload based on the cost benefits.
Okay, okay, got it.
Yeah, yeah. Some workload might be in AWS, some workload will be on Azure. And see, initially, one business, see, the business operate different ways, right? So when it comes to an organization, their organization might be having different acquisition companies, right? So when you say acquisition, they might have purchased some companies. That company might have already been using some other cloud platform. Let's say they might have been using Microsoft Azure, and the parent company, the parent organization might be using AWS. So in that organization, you will have both the cloud. Similarly, when it comes to business unit, different business unit might have their own control, their own choice of choosing the product. So in such cases, there might be chances some business unit or some department, they might choose to run their application or workload on specific cloud platform. So an organization might have their workloads running on various cloud platform based on their business need, demand, and so on. But in general, it is a good practice to have single cloud platform to have better control, better visibility in terms of billing, monitoring, and there are certain benefits of having all your workloads running on a single cloud platform. But again, if the control or if the choice of choosing the cloud platform is with the department or business unit, they might go and choose what they really need. So there are certain scenarios you will see customers using various cloud platform, and sometimes if the cloud offering is competitive enough to cover the cost what they are being offered by the competitor, sometimes they generally migrated to one single cloud platform also I mean over the time. But definitely there are many enterprise organization they are using multi-cloud setup.